So with that, how do you get the degree of unsaturation formula? So I don't want, I can only cover my hand over my screen, but obviously you can see what it says there. But in a sense, we first explore, so first we'll write it down. How do you get degree of unsaturation formula? So first we need to talk about what does being unsaturated means, and we'll find that out by explaining what being saturated means. So a saturated carbohydrate, okay, looks, or hydrocarbon, that would actually, yeah, carbohydrate works too. Either way, saturated versions, think of it as a long chain of carbon and hydrogens. Sorry, we can draw that better. Yeah, we can definitely draw that better. Okay, this is saturated. Why is this saturated? Because it has the max amount of hydrogens per carbon. For example, what does that mean? Each point here is a carbon, okay? Right? And each carbon has a maximum amount of hydrogens it can attach to it. Just like that. Okay? And remember, when we're trying to figure out our formula for carbons, in saturated hydrocarbons, right? It's CnH2n plus 2. That is the formula for it. So you notice if we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons, it'll be C10H22. That is 10 decane. That should be what it's called. But the point being here is that this is a completely saturated hydrocarbon. So now, with that being said, what does it mean to be unsaturated? So with that, let's actually draw it out. Okay, we're actually going to use the same 10. 4, 5, 6, 7, 8, 9. Okay, we're going to use the same 10 here, but the difference here is that there are double bonds present. It doesn't matter how many, as long as one, as soon as one shows up, it's no longer saturated. Okay? And there's actually a way to calculate the degree of unsaturation, aka how many what's it called? How many the number of double bonds, pretty much. Okay? And here actually does a great job of breaking it down. But the point being, right, is that if we were to now label the carbons like we did before, okay, 4, 5, 6, 7, 8, 9, 10, right? But now for the hydrogens, right, you have 1, 2, 3, 4, 5. Because there's a double bond here, it's only one each. And then there's a double bond here, only one. And then this one has 2 again, only one, 3. So you see here, if we actually did the formula, it would be C10 H1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. H16, because there was 3 double bonds, which exactly accounts for 6 of them being lost. So yeah, sorry for all the notifications. So with that being said, let me just double check here. Sorry about this. Okay, so with that being said, exactly that's what it means to be unsaturated. Now what they've done actually is giving us a very nice formula to be able to find out the degree of unsaturation. So now I was able to work on this off screen, and I do know this is correct. So to find the degree of unsaturation, aka how many bonds or rings you should be looking out for, you use this formula here. So what's saying is that you want, for every carbon you have, you multiply it by 2. Okay? Alright, plus 2 plus N minus X minus H. So what this means is that pretty much any nitrogen there you also add, but any halogen or any hydrogen you subtract and you divide everything by 2. And in fact, we're going to use this formula to work on the 2 examples up here, okay? Because I predict that this saturated one will give us an answer of 0, and this unsaturated one will give us an answer of, I believe it will be 3. Okay, so now let's find out. 2C, right? So that's 10 times 2, that's 20, plus 2 plus 0, because there's no nitrogen, minus 0, there are no halogens, and then minus 22. Wow, and that equals 0, because these will cancel out with the 22. Now the C10H16, same thing here. We have 20 plus 2 plus 0 minus 16 over 2. So 22 minus 16, we have 6 over 2. And yep, it is indeed 3. Now you're probably wondering exactly, how did I get 3? And as you notice, we have only 3 double bonds. So whether, this is the tricky part here, right? When it's double or triple, think of it as, in a sense, adding a level of unsaturation, okay? So in fact, we'll actually look at this table here. When there's only 1 degree of unsaturation, that's a very rare case where it has, actually this is an interesting thing, because 1 degree of unsaturation could also mean that it has 1 double bond. So with that being said, I think this is just including rings as well. So rings is the first priority, because for example, if we had only 1 double bond, you'll notice that the hydrogens, instead of 16, it'll be 20. And then, you know, 22 minus 20 is 2 over 2. So exactly. So I would say if we were able to copy this table down, it would be either 1 ring, which is correct, okay, 1 double bond, and 0 triple bonds, okay? That's how I would break that one down. Now, as it goes down in terms of degrees of saturation, exactly, like if you had now 2 degrees of unsaturation, which is now 4 hydrogens missing, quote unquote, in a typical sense like this one, or 2 double bonds, exactly, that's a possibility as well. 2 double bonds. Okay, I see how I wrote it. So it should have been like this, or 0 1 0, because it can definitely have a double bond without a, yeah. So with that being said, that is what we have here for sorry about that. That is what we have here for the degree of unsaturation. Is that definitely memorize this formula here as it is written. It's quite important, because then you can tell yourself what's the degree of unsaturation. And this table here, it helps you break down what you should be expecting. An example that I can think off the top of my head is benzene. Okay, this would be the last example, but pretty much this is C6H6. Using this formula, we have 14, okay, minus 6 over 2. Alright, because we have 6 carbons, okay, multiplied by 2 plus 2. Okay, and 14 minus 6 is 8. Divided by 4, okay. Whoops, I don't know why I put 4. 8 divided by 2, 4, okay. Why? Because this is the degrees of unsaturation. Benzene, if I drew it out with the actual, I drew a ring, because that's like how it likes resonance, the resonance structure. But really, benzene is like this, with 3 double bonds and a ring. So being in a ring itself counts as a level of unsaturation, because the ends aren't free, they have to connect with each other, which is that 1. And then the second one is going to be, I mean, well, the rest of them, the 3 left, is how you add up to 4 in regards to the degrees of unsaturation. So that is actually one of the best examples we have here, because exactly, if the table went far enough to show 4, it would show that that was a possible combination. So for example, if we had a 3 degree of unsaturation, I'm looking at this example here. So if I can highlight it, okay, this is what it could possibly look like. It's no longer benzene. Okay, it's a ring, but with only 2 bonds. So it has 2 bonds, 1 ring, and exactly that's how you still get a 3rd degree of unsaturation. But yeah, oh, they do talk about benzene. Yep, and it is 4 indeed. And they do mention that just because you know the degree of unsaturation and the type of molecule doesn't mean all of a sudden that you know what type of structure it is, because they show there's a bunch of isomers here that still have C6H6, but it's not benzene. These are all isomers of it because they have the same formula. As you can see here in this 3rd example, it has 2 double bonds and 1 triple bond, and triple bonds count as 2 degrees of unsaturation, so you can still get there that 4 degrees of unsaturation. So exactly, all of these are just different examples of a 4-degree saturation of a molecule, or a hydrocarbon in this case. So this is correct. So with that, let's move on to question 3. Hopefully something that's gives a little bit of a breather here. Oh,